So, of course, I'm here at bpmNEXT. I'm not going to talk about BPM at all. I'm going to talk about user experience design. And the presentation is not really about user experience as much as about architecture and design of how Appian's approached building intent-driven and future-proof user experiences for our customers, which is a challenge I think everyone faces. And when we build kind of the UIs, that takes so long to complete the entire solution for our customer set. So anyways, what customers want, as we've seen from 2005 to 2015, UIs are advancing. We have modern design techniques. And if you've ever re-architected a UI for enterprise system, this takes a lot of work. You got to redesign and keep it modern, keep it fresh. But what we're always doing is really the same thing. Enterprise operations share common attributes like text fields, selection menus, signature fields, date pickers, paragraph fields. We're kind of reinventing the wheel over and over and over again, doing like rich text, reporting, grids, sections, icons, and graphics. It's the same thing as it was back in 1980, same thing it is now in 2016. But with that, 15 seconds, I'm actually ahead of schedule with the Ignite format. Customers still want vibrant interactions. Now this is my second violation of the Ignite format. Of course, I'm using how do I show vibrant interaction without animation, and this is what customers want. They want peeking owls, they want selection menus, they want intelligent credit card inputs, they want real-time collaboration, but they want all that stuff at super high volume. Customers like ours at DFW Airport had truckfuls of forms they were pushing around the entire environment. So you got to be able to crank out these forms every few hours with vibrant interaction. And also those forms have to work on all the devices. So within starting a form, within like 0.0 to 2 hours later, they want that form running on a web, running on a tablet, running on an iPhone, running on everything right away, because it has to be high volume production. But not only that, the executive's going to go out, buy an Apple Watch, buy Google Glass, buy a Microsoft HoloLens, and when you go back and tell them, oh, you got to rebuild that form for Google Glass, you got to rebuild that form for Microsoft HoloLens, they don't want to hear it. They just want that form that they built back on the old PC to work now. Now, traditionally, we've always used an architecture model view controller, things like Java Beans, HTML, CSS, Java Servlets. It's a really good architecture for segregation of all the different parts, but each of these also isolates the code into HTML. Of course, there's a lot of frameworks you can choose from. Some of you might chose like AngularJS, jQuery, Knockout, Essentia, Topcoat. These are great accelerators, but you're also a bit overkilling, I'd say, for what you're doing here. Using a full JS framework or requiring your customers to use a full JS framework to actually build their user experiences is first way too complex. It kills flexibility and productivity. It inhibits high volume. You're at the mercy of Google's framework now. If they choose not to upgrade AngularJS, all your customers are kind of screwed. Of course, what you want to focus on is function, of course. That's also the key to good design. Industrial design is all about focusing on the function before the form, and that's what the architecture Appian sales approached in. We want to limit design to common functional elements. So when we capture UI, we're not capturing how it looks really. What we want to capture is how is it supposed to function. We provide functional elements, which are all those base components that customers want. Paragraphs, images, text fields. And when I define a video, so I'm going to move a video field into a design, well, Appian's going to determine the best way the form is going to look. So we automatically render that for a web on all the browsers, or an iPhone, an iPad, a tablet, or Android, whatever it is, we're going to determine that. And they're going to compose interfaces like this, but again, this is just the functional composition. What are the pieces they want? And then it's automatically going to determine the form in the sale runtime engine, giving you the UI that you want for all the different interfaces. This allows that high productivity. But as well, it's a dynamic declarative architecture as well. So you can insert dynamic logic to get those interactive functions that you want, a vibrant interaction using a rules engine embedded inside the system. So applying the rules to actually the interface itself. And this is how it works. So take a look at it. You have 15 seconds to memorize it. But anyways, we'll cover this in more detail after the demonstration, exactly how the architecture flows and all the event handling. But what we tried to focus on here was a server-side environment. Our customers also include the New York Federal Reserve Bank, the Office of Comptroller of Currency. We want all logic to be on the server. There's no way to do a cross-site scripting attack, a SQL injection attack. We want to move everything to the server-side logic so it's unhackable. And as well, we want to capture the intent so we know the intent, we can evolve it over time and always have the interfaces translate the intent to the latest architecture, latest device with having zero rework by the individual customers. So the end goal here is really extreme productivity. Allow us to crank out interfaces extremely quickly, very fast, high volume, vibrant interaction, and protect our customers from basically always being kind of sucked into a JS framework and then, oh, Google Web Toolkit's deprecated that feature, so we got to re-architect all the environments. All right, so let's go into a product demonstration. The demonstration, again, it's architecture, really. I'm talking about UI. So what we're seeing with the demonstration is kind of very light. You're going to see UIs that, hey, I could build that in HTML5, CSS, and you can. What I'm going to show you is first how we actually capture the intent of the design, and then I'm going to show you translating that intent using radically different web architectures, using Google Web Toolkit, using Facebook React, using a native iOS environment, pure native, no web, using a native Android environment. So capturing that one environment using no HTML5 as the main translator, but using our own sail architecture. So this is a form section inside of here. If I go into, let's see if I have a larger one. So sail interface designer. Pretty simple form inside of here. I put in some basic dynamic interaction where I select individual elements. You see the milestone up top moving around. How the sail interface designer works is you have what we call the live view. The live view allows us to basically interact with our environment. So if you use languages like Swift, it's like that new architecture for UI design that as you compose the interface, you can interact with it immediately and start testing in it. You can create test patterns, as well as there's embedded application performance monitoring to actually see the overall performance of the interface as well. Now on the left-hand side is the design view. You have two different ways of working inside the Appian product. I have the design view right here where I want to define, say, column contents. I have sections inside of here. I can navigate to those individual sections, see what's inside the first column content. I have a milestone. If I want to add something underneath that milestone, I have that component library for which I can then choose from. So I can say, oh, well, I'd love to have a paragraph field underneath my milestone, and then go ahead and click on that paragraph field and say, this is a paragraph field. And you see the updates taking place immediately. So again, that live view acts as kind of that validation of what I'm doing and testing the entire environment continuously. If I want to select individual components, I just go ahead and click on that. And you can see it's highlighting that entire section right here. So this is actually an embedded component. So we can take reuse components across other rules, functional elements, and reuse them across other designs. So there's a lot of reusability embedded inside the entire UI architecture. If I want to see that individual component, well, here it is right here, and that's another sail interface. Again, I could add another milestone component, add things like images, videos, barcode scanners, things like this. Now, one of the nice things about functional elements like this is if I want to do barcode scanning can function radically differently depending on what type of device I have. If I have a completely web-based desktop terminal with no camera embedded, how do I barcode scan something? You don't. So we're going to detect the type of device the person's on in a barcode situation and say, well, if that barcode is just a 1990s PC, just put it as a text field, manually enter the barcode. If that barcode is working on an Android device, then we'll activate the native camera on it when they click on that barcode field and actually scan something. If that barcode happens to be connected to a Bluetooth barcode scanner, we can connect Bluetooth connectivity of other devices of a like iOS device, have a Verifone, say, based barcode scanner. It'll automatically activate the Bluetooth connected devices. So each functional component, I just say, I want barcode scanning here. But as it evolves, as I have new ways of capturing barcodes, it automatically adapts the interface to capture those other environments. So that's a good example of the overall functional kind of nature of the environment. So if we take a look at the design here, let's go to this one. So here's the exact same form, rendered in an Appian site. Again, this is the output rendering. Now the thing that looks like a pretty basic form, got, as I said, some pretty basic interaction here. I use the interface designer to compose that. I have some nice dynamic drop downs inside of here so I can see some dynamic logic. But this entire web architecture at the end result is been rendered in Google Web Toolkit as an environment. Now, if you've ever built things like an AngularJS, like AngularJS had a version 1.2, and then they came out with AngularJS 2.0. And everyone know what happened then? Yeah, anyone use AngularJS? Well, they said, oh yeah, all those interfaces you built in AngularJS 1.2, Yeah, forget about them. We decided to re-architect everything because we're Google and we don't care. So we went ahead and rebuilt everything on AngularJS 2.0, and you had no backwards compatibility for a large set of elements. And oh, by the way, we're going to deprecate that stuff. So if you find like a cross-site scripting attack vulnerability in the AngularJS 1.2, we recommend you upgrade to 2.0 instead. So of course, you got to rebuild everything. That's a horrible situation to put your customers in. So what we want to do is say, well, hey, yeah, Git is old and busted. We want to put things in React now. So this looks like, on the outset, just like a new cascading style sheet. It's not. It's basically an entire rendering architecture based on Facebook React instead of Google Web Toolkit. Now this, we can do something like this in just about 6 months. We can port the entire engine to a new rendering architecture and have all of our customers suddenly benefit from a brand new UI architecture with all the other benefits that come along with React. And the intent is all the same, or what we captured is all the same. So those functional elements still work just the way before. I can go through, I can click on the different elements as well. Now if we go to the iOS rendering, there we go. So we have iPad, we have Android. So Android device on the left-hand side. Again, as I click on it, exact same functional behavior as we saw before. So anyways, we'll go to the iPad interface. So again, exact same behavior as I click on it. The big difference with the iPad interface is this is a pure native, no HTML, no phone gap, doing a hybrid. Why do we do pure native? Is because we've always felt pure native is the best. If anyone play Angry Birds? Yeah, probably lots of people played Angry Birds. Did anyone play the web version of Angry Birds?
Oh, yeah, it was terrible.
Yeah, it was terrible. That's why, because it's slow, it's awful. Yes, it looked beautiful. It looked just like Angry Birds in a native application, right? But it was slow as heck. And you will never create a phone gap application or an HTML5 mobile application that performs as well as something that's in the native application container. So that's why we go with the native architecture to have that environment. It's also a protection because HTML frameworks, it's like you're again back to that slide, there's so many different frameworks you can possibly choose from. Well, you got to put your money in one of these other frameworks as far as a software vendor investing in that architecture. Well, what happens when PhoneGap gets old? What happens when AngularJS gets old or when Sencha gets old? You kind of need to rebuild that investment as well. So anyways, so we go through the web architecture, go through a little bit more advanced design here. So of course, what we want to do also is start to build more complete interfaces across the environment. So Appian, we saw interface design. We saw kind of individual renderings of different architectures. Now let's kind of build a whole UI from scratch. And what we have inside the architecture is called the sites environment. So the sites environment allows you to create kind of custom mobile applications, web applications, literally in like 2-3 minutes inside the environment. So if I want to create like let's just go create one from scratch. Let's say I want to create a new site. I'm going to call it customer support. I'm just going to give this a URL CS. And sites work very similar to interfaces where I have functional components. Here I have sites that have layouts. It's just defining the overall layout navigation of these. Now I have two different controls here basically. I can say, well, what do I want the site to point to? So I have different pages. Well, I want to have maybe my customer list. And I have a bunch of SVG icons to choose from here. So I can say, well, I want to have a list of people. And Appian essentially builds what we call functional elements inside our product. So at the core design element, you're building processes which have actions, so initiating a process. I have record lists, records inside Appian, kind of our case management construct, where I have a data source I'm going to navigate inside the environment. And I have reports. I want to see reports inside the environment as well. So let's say, well, this is going to be one of my record lists, and I have a pre-built record list here called customer, and that's it. If I want to define things like internationalization, I can use a rule to define internationalization of the text, or I can have conditional visibility based on permissions or other types of dynamic rule logic. As I come inside of that site, there's my customer list. Let's say also I want to have my service requests. And let's make this like a hand. There we go. And that's going to be, again, one of my existing cases of customer service request. As I come in as well, let's say I want to create maybe a new request. And let's say this is going to be maybe some kind of a plus symbol. I have a variety of pluses. Let's say that's going to be we'll do a basic service request here. And let's say I also want to capture new orders. It's going to be a shopping cart, of course. And of course, that's going to be one of my process models to create a new order. So I'll just type in the word new. There it is. And maybe I have someone who wants to be a new customer as well. So let's say new customer. And then we'll take user. And there's a user plus right there. We'll say new, create new customer. All right. So it looks kind of nice. I got, and boom, just like that. Here's my application. So here's my list of all my cases and my customers. If I want to have that search, we have an embedded search capability to say, well, there it is. I want to see all Mac industries. Click on the dashboard, bring all the information forward. If I want to see all my service requests for all my customers, I can go ahead and say search all the information. If I want to create a new request, I have all the customers right here, fill out the information, create a new order. So again, using the SAIL architecture, we can create these dynamic experiences where I dynamically choose information, maybe type in the word phone. As you can see, it's very responsive. The nice thing about this, 100% of the logic is server-side. So what we're doing here is actually, I type in the word phone, sending a request back to the Appian server. It's returning back then on the Appian server what is essentially the delta of the interface, and saying the delta is this content down below, and then it's going to say, well, now you need to serve this content. As you can see, even though it's doing this, the server right now is running in a cloud environment, hitting the internet, and it's hyper responsive. So I can say, let's say I want a laser printer. Very quickly, bring up all the images dynamically fast right inside the system just like that, and doing all my order calculations just like that. So do a phone like that. And let's go ahead and hit next. Then I can have, again, dynamic logic through the whole thing, all conducted server side, submit the order. But let's go ahead and take this a step further. Let's go ahead and brand this. If I want to say I have a logo I want to apply, let's see, Parsec Express logo. Go to my fav icon, Parsec Express. There's a fav icon. Let's choose and let's just make the selection color black. So hit save like that, boom, like that. And now before I had my Appian branded, now I have a Parsec Express branded with all the exact same functionality. Now let's pop over to mobile experience. So my mobile experience, let's go back and say I need to set up a new account. We could hard code these to the individual environments. So I'm just going to that URL I just set up, but we could create native mobile applications that are kind of pre-set up to go to that environment. Log in as James Baker. There we go. So not only do I have a mobile application or a web application, but I also have a branded mobile application. Branded, you can see Parsec Express, color branding's all carried forward, exact same functionality. And we always guarantee with our SAIL interfaces that there's zero drop-off in functional behavior between the mobile experience and the web experience. So there's not a single function that you could do, say in web, that you couldn't do also on the mobile device. And that's a very important kind of philosophical goal for us, is to make sure that you have a parity experience between the web and the mobile. And of course, you have a lot of capabilities, like if I want to go offline now. Well, now I'm offline. All the SAIL interfaces can be also enacted for offline capability. We have data caching built into the product. So I have even though I'm offline, I have my full customer list. I can go ahead and take information. I can choose a file, take a video, record a voice note. Let's go ahead and just snap a video or a picture. There we go. There's my picture. I could continue to do more, request or email, like this, hit submit. And it's a very seamless offline experience. Down below, you see then the user has one action pending. So I can see my pending action queue. So this is my outbox waiting to submit. As my outbox is inside there, I can always go back and revisit, modify the information before I come back online. If I come back online now, you're going to see that pending action queue submit. There it goes. It's submitting. And if there's any error, we can do server-side validation. So if there's any type of mistake or input information, the user can get that submitted back to them saying, hey, you have a submission error inside of this one. So if I go back to my pending actions, looks like it's still syncing up with the server right now. So anyways, and you know what? I disconnected my VPN when I went offline. So that's why it's still saying offline right now. So anyways, that's the goal of the Appian Sail architecture, is really to enable our customers to very rapidly build these interfaces and have that seamless functional behavior allow us to translate it to any other architecture you want. As I promised, we'll go back and revisit as a close this Sail UI architecture. But essentially where the magic happens with this is very much on the client side. You have web client renders, you have a UI component rendering engine. So this is what we actually write in the client-side environment. That client-side rendering engine is actually written in Git, written in React, written in native iOS, written in Android. So we have teams that write that engine and translate to all the other environments. Then of course you have the Sail request builder. This builds the communication, so the Delta communication with the server handler, HTTP response handler, and then it's going to pass the context. So if the Sail interfacings have context to a specific case, specific process, specific type of action, we're going to pass a context information. We're going to do the re-evaluation handling to find out the delta, what actually changed inside of here. This is all server side, and then we're going to send it right back up. So all the rule logic actually occurs right here, all that dynamicism. And then as it's going to communicate back up, again, Sail response handler, UI component rendering engine is going to render that, and then send it right back to the end interface. So that's how that works. So open up to questions.